So little drop, I can understand. So it is somewhat inconvenience for everyone, including myself. So still we need to discuss the topic. That's why I came again. So welcome to the student the brand. So welcome to the student the brand, everyone. So now we are discussing. Hey Anhat, how are you? After a long time. What happened? Myopia, 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 myopia. Near distance we can see far distance we can see myopia, myopia, myopia. For that correction we are using concave lens, concave lens, concave lens, concave lens. Hypermetropia, 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 hypermetropia. For a distance we can see, near distance we can see hypermetropia, 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 hypermetropia. For that correction we are using convex lens, convex lens, convex lens, convex lens. What is this combination? Song me now. So I'm singing songs. So that is related to concept only. That's why. New Cartesian sign convention. New Cartesian sign convention. All distance measured from the pole. Distance are positive along the instant trace. Distance are negative opposite to instant trace. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. All distance measured from the pole. Distance are positive along the instant race. Distance are negative opposite to instant race. Distance are positive above the principal axis. Distance are negative below the principal axis. So that is introduction of the class. So this is Shiva sir. Today we are discussing generally, actually in the previous class while we are discussing, due to power cut we can't able to discuss the points. Now I am again resuming. So if you like this content, do like, share and subscribe to Student Brand. So myself, I am Shiva sir. I am Shiva sir from Student Brand. Decide, dedicate, put the target, reach until you succeed. So with a strong dedication, with a strong determination, with a strong mindset, if you have, definitely you will win in your field. So fix the target, work for your goal, do hard work. The hard work should, okay, so hard work only should feel, hard work should feel ashamed by seeing. Okay, so like that you have to work out, like that we have to work out. Okay, so make sure that your work should speak always. Hi everyone, so everyone, hi. So myself, I am Shiva sir from Student the Brand. So we are discussing about uh, terms related to spherical mirror. So here I am considering the center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part is called center of the curvature. Middle point of the mirror is called pole. The distance between center of curvature and pole is called radius of curvature. Line joining of the principal axis, line joining of center of curvature and pole. Line joining of center of curvature and pole is called, line joining of center of curvature and pole is called principal axis. Are you listening or not? Listen careful. So center of curvature, line joining of center of curvature and pole is called, line joining of center of curvature and pole is called principal axis. Line joining of center of curvature and pole is called principal axis. Line joining of center of curvature and pole is called principal axis. Line joining of center of curvature and pole is called principal axis. Line joining of center of curvature and pole. Center of curvature and pole is called principal axis. Come on, everybody. Principal axis, line joining of center of curvature, line joining of center of curvature, line joining of center of curvature, pole, center of curvature and pole, center of curvature and pole is called principal axis. So here you need to understand the center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part. So the distance between center of curvature and pole is called radius of curvature. So everybody hi. Distance between center of curvature and pole is called radius of curvature. And fourth one you are considering. Fourth one if you are taking fourth one. So after reflection, all light rays will meet at one point on the principal axis. After reflection, all light rays will meet at one point on the principal axis. After reflection, all light rays will meet at one point on the principal axis. That is called focus. After reflection, all light rays are meeting at one point on the principal axis called focus. The distance between focus to pole is called. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. So are you listening? Are you listening or not? So listen careful. Listen here. The distance between focus to pole is called. The distance between focus and pole is called focal length. Come on. Focal length. Focal length. Focal length. Focal length. Come on. Focal length. The distance between focus to pole is called focal length. Yes. 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 Now, so the width of this. So next one, 6-1. 6-1 you are considering. 6-1 you are considering. So the radius of curvature, center of curvature, pole is there, focus is there, focal length is there. So width of the mirror is called aperture and principal axis. Principal axis I didn't write. Principal axis, principal axis. Come on, everybody sing with me. Principal axis, principal axis, principal axis, principal axis. Line joining of center of curvature and pole is called principal axis, principal axis, principal axis, principal axis, principal axis. And the 7th one, width of the mirror, width of the mirror, width of the mirror, aperture. Come on, width of the mirror is called aperture. 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 Once again, center of the imaginary sphere. Center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part is called center of curvature. Midpoint of the mirror is called pole. Midpoint of the mirror is called pole. Line joining of center of curvature and pole is called line joining of center of curvature and pole is called line joining of center of curvature and pole is called principal axis. Principal axis. Come on, principal axis, principal axis, principal axis. Line joining of center of curvature and pole. Center of curvature and pole is called principal axis. Principal axis. Principal axis. Come on. After reflection, all light rays are meeting at one point. After reflection, all light rays are meeting at one point. Do you know? After reflection, all light rays are meeting at one point is called focus. That is also not called principal of focus. Principal of focus. 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 Come on. You focus. After reflection, all light rays will meet at one point. That is called focus. That is also known as principal focus. That is also known as principal focus. So the distance between focus to pole is called. The distance between focus to pole is called. The distance between focus to pole is called focal length. Come on, focal length. The distance between focus to pole is called focal length. Line joining of center curvature and pole is called aperture. 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 Width of the mirror is called aperture. Width of the mirror is called aperture. Once again, center of curvature, pole, radius of curvature, principal axis, focal length, aperture, aperture, aperture. Clear? Are you understanding? Are you understanding? Are you understanding? Yes. So that is about terms related to spherical mirror. Terms related to spherical mirror. Come on, we are going to the next one. Come on, we are going to the next one. Ray rules of image, ray rules of concave mirror, ray rules of concave mirror. So everybody hi, everybody hi, everybody hi. Welcome to the class, student Dibrand. This is your Shiva sir. This is your Shiva sir. My channel name is student Dibrand. Remember, I am teaching physics. I am teaching physics. I am teaching physics. This is Shiva sir, my brand. Student the brand. Channel name. Channel name is Student the Brand. Come on, come on. Everybody listening or not? Everybody listening or not? This is Shiva sir. This is Shiva sir. You are listening? Shiva sir class. Come on, everybody, everybody. Welcome to the class. So we will see now. So I'm going to the next one. So mirrors related to concave mirrors. When the object is so rare rules of concave mirror, 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 rare rules of concave mirror. Come on, everybody listen. Are you listening or not? Rare rules of concave mirror, rare rules of concave mirror, rare rules of concave mirror. Come on. Very good. So here you can see. So concave mirror, concave mirror, concave mirror, concave mirror. So I am taking here. So first point is, so concave mirror. When you're drawing the concave mirror, you should draw like this. You have to place the coating. You have to apply the coating. You must apply the coating. Principal axis, pole, focus, center of curvature. Every time you are drawing the mirror, 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 you must represent pole, focus, and center of curvature. Every time when you are drawing the mirror, you must represent the pole, focus, and center of curvature. Come on. First point is, after reflection it passes through focus. After reflection it passes through the focus. That is the first rule. Come on. Second rule is so if the light ray is passing, come on everybody, pole, focus, center of curvature. If the light ray passing through the focus, come on everybody, if the light ray is passing through the focus, if the light ray passing through the focus, after reflection it passes towards infinity. If the light ray is passing through the focus, after reflection it passes parallel to the principal axis, moves towards infinity. Come on. So I'm taking like this. Third one. Do you know? Are you understanding? Are you understanding or not? When the light is incidenting, when the light ray is passing along the normal line, it reflects back into the same. It reflect back into the same line. Are you understanding or not? When the light is incidenting along the normal line, it reflect back into the same path. It retraces its original path. Yes, here also same thing. If the light ray is passing like this, so pole, focus, center of curvature. If the light ray passing through center of curvature, after reflection it retraces its original path. Original path. Yes. Next one, last one. Fourth one, I'm going to the fourth one. Come on, everybody. So if you like this content, do like, share, and subscribe to Student the Brand. This is your sir from the Student the Brand. Fourth one, I'm taking the fourth one. Come on, everybody, listen here. Pole, focus, and center of curvature. Come on, focus here. You're understanding one thing. This is very, very important. So you have to look into that. Here you have to look at that. So what is that? So you know one thing. So we know one thing. Reflection, reflection, right? You know the reflection when the light incident on the plane mirror reflect back into the same medium. When the light incident on the plane surface, it reflects back into the same medium. Here also same thing. When the light is incidenting at the pole, if the light ray incident at the pole, it reflect back. That is the reflection. This is a reflection. That is a reflection. Yes or no? Yes or no? Yes or no? That is the reflection. When the light incident at the pole, it reflect back into the same medium. That is called reflection. There in plane mirror, here it is the concave mirror. Yes. What is this mirror? Concave mirror. Come on. Welcome to the class. I am Siva, sir. Next one, convex mirror. Coming to the convex mirror. If you are taking the convex mirror also same thing. This is a convex mirror. Both are same. Convex mirror and concave mirror. When the light incident on it, both light rays will take place. I will show you how we have to take. I will show you. Focus. Come on, focus. So when the light is, this is the pole. Focus, center of curvature. The light incidenting on the mirror, it reflect back. If you extend that line, are you understanding? If you are extending that line, that will passes through the focus. Yes, that will passes through the focus. Come on, it will passes through the focus. That is the first one. Coming to the second one. Second one. Come on, second one. This is the pole. Focus. Center of curvature. This is the focus. This is the focus. This is the pole. This is the center of curvature. This is the pole. This is focus and center of curvature. Pole, focus, center of curvature. Pole, focus, center of curvature. Pole, focus, center of curvature. If light rays passing through the focus, after reflection, it reaches towards infinity. When the light is incidenting on the convex mirror, after reflection, it moves towards infinity parallel to the principal axis. So here I'm taking. Next one, third one. Come on, third one. Pole, focus, center of curvature. Pole, focus, center of curvature. Pole, focus, center of curvature. If the light ray incident at center of curvature, it retraces its original path. If the light ray incident at along the center of curvature, if the light ray passes through center of curvature, it reflects back. It retraces its original path. Next one, fourth one. Come on. This is a pole, focus, center of curvature. What is this? Pole, focus, center of curvature. Pole, focus, and center of curvature. When the light incident on it, it reflects back. When the light incident at the pole, when the light incident at the pole, it reflects back. It reflects back like a reflection. This is is about ray rules of concave mirror and convex mirror. These are the ray rules of concave mirror and convex mirror. If you are going to the bar, you need weapons. If you are going to the exam hall, you need ray rules to draw the image formation of concave and convex mirror. Remember, very, very, very important. If you're doing war, you need weapons. You need weapons or not? If you're doing war, you need weapons. If you're going for exam, you need pen, exam pad. Yes or no? You should have content in your brain to write on the paper in the exam hall. Yes or no? Yes or no? Here also, if you want to draw the image formation of concave mirror and convex mirror, you need ray rules. What are the ray rules? How many ray rules are there? 4 ray rules are there. 4 ray rules are there. How many are there? 4 ray rules are there. Are you understanding or not? How many are there? 4 ray rules are there. How many ray rules are there? 4 ray rules are there. Come on. Now is the point. You need to understand image formations. Come on, we will discuss about image formations. Come on, image formations. You know image formations? Concave mirror image formations. How many light rays are required to form the image of the object? Come on, everybody say. How many light rays are required to form the image of the object? How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Yes or no? 2 light rays. How many light rays are required? 2 light rays are required to form the image of the object or not? Yes or no? How many light rays? 2 light rays are required to form the image of the object. Now you are seeing, see, how many light rays are required to form the image of the object? Minimum 2 light rays are required. So I am taking the concave mirror. So first one, come on. I am taking the concave mirror like this. Concave mirror coating. Every time when you are drawing the concave mirror, you must apply the coating. Every time you are drawing the concave mirror, you must apply the coating. Yes or no? You must apply the coating. Every time you are drawing the concave mirror, you must apply the coating. So to understand which mirror it is, sometimes students, they will do mistake here itself. They won't draw the coating. How we will understand it is, how we will understand whether it is concave mirror, convex mirror, you must. Are you understanding or not? You must apply the coating. You must draw the coating lines. Yes, then we can say that is concave mirror, convex mirror. Are you understanding or not? Concave mirror, convex mirror depend on coating. So I'm considering the principal axis. Come on. This is what? Principal axis. What is this axis? Principal axis. So this is pole. This is the pole. This is focus. This is center of curvature. What is this? Did you see this one? That is pole. What is this one? Focus. What is this one? Center of curvature. Yes, center of curvature. If the object is placed at infinity, object is placed at infinity. How many light rays are required to form the image of the object? How many light rays are required to form the image of the object? How many light rays? Minimum. 2 light rays are required to form the image of the object. Yes or no? 2 light rays are required to form the image of the object. Yes or no? Yes. Now use that. 1 light ray I am taking like this. So after reflection, it passes through focus. So one more light ray I am taking like this. After reflection, it passes. Yes. After reflection, it passes. Yes, it passes. Yes, it passes through it passes. After reflection, I am taking here. After reflection, it passes. Yes, it passes. Yes. How many light rays? So remember one thing. You should remember one thing. You should remember one thing always. Incident ray one direction, reflected ray one direction enough. No need to draw entire the line, all directions, direction. Every time you draw the direction, it is only direction. There won't be any ray. That's why you must draw one ray direction. Yes or no? Here you can see. This is the one day direction. This is one day direction. This is one. That's enough. You notice sometimes how you will people. So they will do like this. Here one, here one, here one, here one, here one, here one. This many are required. This many are required. This many are required. Yes or no? This many are required. You tell me this is required. This many directions are required. No. No. This many directions are not required. Understand? Single one, universal one direction, proper direction. Yes or no? Yes or no? Tell me yes or no. Tell me yes or no. Single direction, one direction. That is enough. One direction enough. You don't need to draw each and every line. Each and every line is not required. Are you understanding or not? One direction is enough. Object is at infinity. Image will form at focus. Object is placed at infinity. Image will form at focus. Object is placed at infinity. Image is forming at focus. Object is placed at infinity. Image is forming at focus. What is the nature of the image? Nature of the image and size of the object. What is the nature of the image and size of the object? Hey, object nature is real inverted and large. Sorry, highly diminished. This is highly diminished. Object is placed at focus, right? Real inverted and highly diminished. What is that image? Real inverted and highly diminished. Real inverted and highly diminished. Object is at infinity. Image will form at focus. Object is at infinity. Image is forming at focus. Do you know the nature of the image? Real, inverted and highly diminished point size image will form at focus. Highly diminished point size image will form at focus. Yes. Next one. Come on. Second one. So draw the concave mirror. Okay. So draw the coating. And draw the principal axis. Are you drawing the principal axis or not? Principal axis. This is the principal axis. Now I will place. Come on. Pull. Focus. Center of curvature. Pull. Focus. Center of curvature. Come on. What is that? Pull, focus and center of curvature. Pull, focus and center of curvature. So I am taking. So object is placed beyond center of curvature. Object is placed beyond center of curvature. How many letters are required to form the image of the object? Minimum 2 letters. One letter I am taking like this. After reflection passes through the focus. Another letter I am taking through center of curvature. Center of curvature. Come on. Object is placed at beyond center of curvature. Where image will form? Where image will form? Where image will form? Where image will form? Between C and F. Between between C and F. Between C and F. Between C and F. Object is placed beyond center of curvature. Beyond C. Where image will form? Between C and F. Between C and F. What is the nature of the image? Real inverted, real inverted, real inverted, real inverted, real inverted, real inverted, and diminished, 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 diminished. Diminished means what is that? Diminished means compared to the object, compared to the object, compared to the object, image size is decreased. Compared to the object, image size is decreased. Decreasing, reducing, that is the diminished meaning. Are you understanding or not? Diminished means image size will be reduced. Image size will be reduced. Come on, come on, come on, everybody, come on, listen here. Next one, next one, next one, next one. Third one, very, 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 very important. Very, 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 very important. Very important. Very, 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 very important. Dun, 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 dun. I am taking the object. I am checking this is the pole. Focus. Center of curvature, pole focus, center of curvature, pole focus, center of curvature, pole focus, center of curvature. Object is placed at C. Object is placed at C. Where image will form? Object is placed at C. Where image will form? Where image will form? Where image will form? Where is image will form? Image will form at center of curvature itself. Image will form at center of curvature, center of curvature. Object is placed at center of curvature. Image will also form center of curvature. Do you know what is the nature of the image and the size of the image? Do you know the nature of the image and size of the image? Nature of the image is real inverted and size of the image is same size. Same size of the image. Both are same. Both are same. So I'm taking one light ray here like this. After reflection, it passes through focus. So another light ray I am taking here. So the light ray will be incidenting. So here you can consider pole, focus, center of curvature. So how many, C, if you are placing the object at C, image also will form at C. So I'm taking like this. So it passes. Another letter I'm taking at the pole. So here. So object at C, image will form at C. Nature of the image is, come on, what's the nature of the image? Real inverted and real inverted and real inverted and real inverted and same size. Come on, object is placed at C. Image will form at C only. Image also will form at C. What is the nature of the image? Real inverted and real inverted and real inverted, real inverted, and size of the image is same size. Same size. Are you understanding or not? Same size. Object is placed at C. Image also will form at C. Yes. So real inverted and size of the image is same size. Same size. Same size. Yes or no? These are the image formations. Image formations by concave mirror. Concave mirror. Image formations by concave mirror. Image formations by concave mirror, image formations by concave mirror. Are you understanding or not? Are you understanding or not? Are you understanding or not? This is Siva sir. My channel name is Student the Brand. If you like this content, do like, share, and subscribe to Student the Brand. Come on, click one like if you like the content explanation, boss. Click, or just tap and click, tap and like button, boss. That's enough. That's enough. That's enough. That is more than enough. Yes or no? Come on, ready? Next one. We are going to the next one. Object is placed. Concave mirror. Object is placed between C and F. Object is placed between C and F. Come on. Object is placed between C and F. So I am taking the fourth one. Object is placed between C and F. So this is the pole, focus, center of curvature. Object is placed. You know one thing. Object is placed between C and F. Object is placed between C and F. Where image will form? Oh my God. Image will form beyond C. Object is placed between C and F. Image will form beyond center of curvature. Beyond center of curvature. I am taking beyond center of curvature. I am taking how many letters? One letter I am taking here. It passes through. Focus. Another letter incident at the pole. It incidented. Those light rays will reflect here. Object is placed between center of curvature and pole. Object is placed between center of curvature and focus. Image is forming. Image is forming beyond center of curvature. Can you tell me what is nature of the image and size of the image? Yes, nature of the image is real inverted. Nature of the image is real inverted and size of the image is enlarged image. Size of the image is enlarged image. If the object is placed between center of curvature and focus, where image will form? Beyond center of curvature. What is the nature of the image? Real inverted and enlarged image. Are you understanding? What is the nature? Real inverted. What is the size of the image? Enlarged image. Compared to the object, image size is increased. Yes or no? Say yes or no. If you say yes, click on like button. Object is placed between C and F. Image will form beyond C. Nature of the image is real and inverted. Size of the image is enlarged image. Size of the image is enlarged. Size of the image is enlarged. Size of the image is enlarged image. Size of the image is enlarged image. Size of the image is enlarged image. What is the nature of the image? Real and inverted. What is the nature of the image? Real and inverted. Now you are going to the next one. Come on, fifth one. I'm talking about fifth one. So be ready, everybody. Be ready. Practice with me. I'm taking convex, concave mirror, 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 concave mirror. So this is pole, this is pole, this is focus, this is center of curvature, center of curvature. Do you remember? Do you remember? Do you remember? This is pole, this is pole, this is focus, this is center of curvature, center of curvature, center of curvature. If the object is placed at focus, 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 image is forming at infinity, image is forming at infinity, image will form at infinity, object is placed at focus, image is forming at infinity. Do you know the nature of the image is real and inverted, nature of the image is real and inverted, and size of the image is enlarged image, size of image is enlarged image, size of the image is enlarged image. Come on, so you are considering one light I'm taking here. So after reflection passes through the focus, passes through the focus. So one light I'm taking, one more light I'm taking. After reflection, after reflection, after reflection, after reflection, object is at F, object is at F, object is at F, object is at F. Image will form it, image will form it infinity, image will form it infinity, image will form it infinity. Yes or no? Yes or no? Image will form it infinity, image will form it infinity. Nature of the image is real and inverted, real and inverted, real and inverted, real and inverted, real and inverted. And size of the image, size of the image, highly enlarged, highly enlarged, highly enlarged. Next question, by listening that question you'll get goosebumps. By listening that question you will think about board exam. By listening that one you will see in unit test. By listening that one you will see on your pre-board exam. By seeing that question, by listening that question, by practicing that question, you will get goosebumps, you will get vibration. You know that question once comes in many applications. You know, dentists will see by using this case. They will observe the teeth of the patient, palmist, so they can see by using this case. So in the history of all mirrors, concave mirror, convex mirror, plane mirror, among all these three mirrors, only one mirror will get virtual erect and enlarged image, that is concave mirror. That is the last case. That one is the last case. Come on, everybody listen here. That is the last case. Definitely you will get this question in exam. Very, 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 very important. By listening this question, this question, exam papers will be in fear, exams will be in full tension, exam paper will be in fear. Our pains will get aware of it. Our pains will be moving away from this question, because many times you are going to practice this question. Are you understanding or not? You are going to practice many times this question, because this is in the history of mirrors. Very, 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 very important. By seeing these questions, so your exams will get flourish. So be happy. Your exams will get happier. That type of question it is. That type of question it is very easy, at the same time very important. 3 mark question you will get. In the exam they will give for 3 marks. Yes or no? They will give for 3 marks this question. That one. If the object is placed, so this is the pole, focus, center of curvature. Object is placed between F and P. Object is placed between F and P. One light ray I am taking like this. After that it passes through the focus. Another light ray I am taking. Another light ray I am taking at the pole. Another light ray I am taking at the pole. In the history of mirrors, in the history of mirrors, come on, the introduction of the virtual image. So you have to do claps. You have to do claps. You should. Background music must be there for this image formation. Background music must be there for this image formation. Background music must be there for this image formation. That is extraordinary, marvelous, mind-blowing, amazing diamond question. More than a diamond, more than a, in the history of mirrors, in the history of mirrors, in the history of mirrors, concave mirror, convex mirror, whatever the mirror comes, whether it is concave mirror, whether it is convex mirror, whether it is plane mirror, in all the mirrors, only one mirror will form, always virtual, erect and enlarged image. Virtual, erect and enlarged image. That mirror is called concave mirror. That is, object is placed between F and P. Object is placed between F and P. Image will form here. Come on. Dun, 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 dun. See the vibration. The vibration, you have to feel it, that vibration. So the image will form here. The image will form. What type of image is? Virtual, erect and enlarge. Virtual, erect and enlarge. By saying this question, you know that vibration, that feeling of vibration. So once this question, if you practice, you will get 3 marks. In our slip test, again I am saying, in our slip test, unit test, midterm, pre-final, any test, any exam, if the question comes from this chapter, this last case is highly important. In emergency case, we need oxygen. In emergency case, we need oxygen. If you are going to the exam hall, you are going to write physics exam, CBSE Grade-10 physics. If you are going to write CBSE science Grade-10, in that physics is there. In that light reflection refraction chapter is there. In that, in the mirror, in the concave mirror, this last case is very, very important. Very, very important. Very, very important. Keep in mind, this is Siva sir. This is Siva sir. My name is Siva sir. My channel name is Student the Brand. If you like it, click on like button. Click on like button. Once you hit the like button will feel decide. Choice is yours. Okay, so here I am considering object is placed between F and P. Image will form behind the mirror. Image will form behind the mirror. Nature of the image is virtual, erect and enlarged. So if the object is placed between F and P, image will form behind the mirror. Nature of the image is virtual, erect and enlarge. Is it clear or not? Clear? Yes. So that's enough. That is about concave mirror image formation. Next we are going to the convex image formations. Convex image formations. Only two cases. After that we will conclude that. Only 2 image formations are there. We'll complete it. So within soon we'll complete it. So there is nothing is there. So there is nothing is there. We will complete soon. So listen carefully. Convex mirror. Only two cases are there. Object is placed at infinity. So I'm taking this the pole. This is the pole, focus, center of curvature. Pole, focus, and center of curvature. Object is at infinity. Light rays are coming parallel to the principal axis. Light rays are coming parallel to the principal axis. After reflection, those light rays will meet at focus. Those light rays will meet at focus. So object is at infinity. Image will form at focus. Image will form at focus. Nature of the image is virtual, erect and highly diminished, because it is point size image is forming. Point size image is forming at focus. So second one, so this is the first one. Coming to the second one, object is placed anywhere between. Object is placed anywhere between. So this is the pole, focus, center of curvature. Object is placed anywhere between pole and infinity. One light I am taking like this. It reflect back. So after that is it incidenting at the pole. It reflect back. So if you are extending these light rays, the image will form here. The image will form. So object is between P and infinity. Image will form between P and F. So nature of the image is virtual, erect and diminished. Virtual, erect and diminished. Only two cases are there. 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 Next one you see, by listening that one, definitely you'll get goosebumps. Very, very important. I'll see that. So very, very important, very, very important question. So see that. Sign conventions. So I'm taking the concave mirror. Come on, concave mirror. This is the pole. Focus, center of curvature. In the direction of incident rays, all measurement will be taken from the pole. In the direction of incident rays, object distance, image distance, focal length, radius of curvature. Object distance, image distance, focal length, radius of curvature. Object distance, image distance, focal length, radius of curvature. Positive, opposite to incident rays, all are negative. Object distance, image distance, focal length, radius of curvature. Above the principal axis, height of the image and height of the object positive. Below the principal axis, height of the image and height of the object positive. So if you are taking the coordinate axis, all measurement will be taken from the origin. So in this direction positive, opposite direction negative, above it is positive, below it is negative. So the same thing the Siva sir is making very easy. The Siva sir is going to make it very easy. New Cartesian sign convention, new Cartesian sign convention. All distance are measured from the pole. Distance are positive along the incident rays. Distance are negative opposite to incident rays. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. All distance are measure from the pole. Distance are positive along the incident rays. Distance are negative opposite to incident rays. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. All distances are measured from the pole. Distance are positive along the instant race. Distance are negative opposite to instant race. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. All distance measured from the pole. Distance are positive along the instant race. Distance are negative opposite to instant race. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. All distance measured from the pole. Distance are positive along the instant race. Distance are negative opposite to instant race. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian sign convention. 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 All distance measured from the pole. Distance are positive along the instant race. Distance are negative opposite to instant race. Distance are positive opposite to instant. Distance are negative opposite to instant race. Distance are positive along the instant race. Distance are negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. All distance measured from the pole. Distance are positive along the incident race. Distance are negative opposite to incident race. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian sign convention. 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 Okay, so I hope it is very clear. So that is about sign conventions, New Cartesian sign conventions. I hope you like it. So thank you so much for your support and joining and joining in the class and interact with me. I'm very happy for you all. So thank you. Only one word is not sufficient for telling, but still, if I'm not saying that one, so I can't express in another way. So only one word. Thank you so much for joining and attending the class. So this is our Siva sir from Student Brand. So next, still so many are there. So 2 more points. Mirror formula 1 by f equal to 1 by v plus 1 by u, and magnification equal to m equal to minus v by u. So there's a magnification and mirror formula, and that's enough. So still few more points are there. So you can join to the tomorrow class. So tomorrow class timings: every day morning 11 a.m. taking class, and 3 p.m. evening time, 6 p.m. evening time, and 9 p.m. 11 a.m. 11 a.m., 3 p.m., 6 p.m. and 9 p.m. So these are the class timings. If you like this video, please do like, share and subscribe to Student the Brand and inform to your friends. So ask them to join to the class. You can see. So every day 11 a.m. 11 a.m. first one, second one 3 p.m. evening time, and 6 p.m. evening time, and fifth one 9 p.m. 9 p.m. So everyday live classes. Everyday live class timings. Live class timings from Student the Brand. Student the Brand. Shiva sir. By Shiva sir. So thank you so much for joining. So hope you like it. So if you like this content, do like, share and subscribe to Student the Brand. Thank you so much. So everyday live class timings 11 a.m., 3 p.m., 6 p.m., 9 p.m. So 6 p.m. I'm taking for grade 11 students, grade 11, and here 3 p.m. grade 10 and 12. Here also grade 10 and 12. So 2 classes. Here also for grade 10 and 12 students. Only here grade 11 students. Grade. Okay. So timings. So I hope you like it. So thank you so much for joining and attending the class. So see you soon in the classes. Keep attending, keep motivating, keep encouraging, keep supporting. Until then, thank you so much.